So welcome to chapter 9. We have one section in chapter 10. But other than that, chapter 9 is our last chapter. We're almost there. So good job getting this far. Congratulations. Thank you for all your hard work. And as we start chapter 9, I just wanted to remind you where we've been in chapters 7 and 8. So chapter 7, as you might recall, was all about confidence intervals. So we had confidence intervals. And we did those confidence intervals about proportions. And then we did confidence intervals about means. And then we did confidence intervals about standard deviations. All right, so we got all three of those ideas. We did sample size for all three of those also in chapter 7. So we got all those. And then we moved on to chapter 8. And we focused on this new idea of hypothesis testing. And as we moved through chapter 8, we had a familiar progression where we tested hypotheses about proportions. And then we tested hypotheses about means. And then we tested claims or hypotheses about standard deviations. So that was chapter 7 and 8. In chapter 9, we move on to a slight variation on a theme. So far in chapter 7 and 8, it's always just been about one group. And in chapter 9, we're going to compare two groups to each other. But we're going to do a pretty familiar dance here in that we are going to look at comparing two proportions. And then we're going to look at comparing two averages, two means. And then we'll look at comparing two standard deviations, or the standard deviations of two groups, I should say. And they probably could have split this up into two separate chapters again, but at this point, they say, hey, you already know confidence intervals. You already know hypothesis testing. We don't have to teach you the big ideas. So they do confidence intervals and hypothesis testing together. So in 9-2, we will do confidence intervals about two proportions, and we'll do hypothesis tests about two proportions. Sample size isn't really so much of a thing here in chapter 9 because we're looking at two different groups. And there's just too many combinations of one group being big, the other group being small, or maybe both groups being medium-sized. There's too many answers to the question, right, of what sample size do you need. So we're not going to tackle that. And I think really what we should do is just go ahead and jump right into a homework problem. There's really no new technique here. There's just some new interpretation. And that's really, as statisticians, that's what we want to focus on. Not so much really the number crunching, is saying, what are these numbers actually telling us? Okay, so let's talk about ginkgo. So this is number 8 from your homework. Ginkgo biloba. Ginkgo biloba. It's one of those herbs that was trendy for a while and people thought it cured everything. This is particularly about whether or not it works on preventing dementia. So they've got the study, they've got some elderly patients that were given ginkgo, and some other elderly patients that were giving a placebo. So there's our two groups. We've got one group that got the treatment, one group that got the placebo. And we want to say, is there a difference between these two groups? And the numbers are there. And they cited their source, and they said use a 0.01 significance level, so they're starting to talk about testing the claim. And notice their instructions here. Part A says test the claim with a hypothesis test. B says test the claim by making a confidence interval. And C says, does it work? Okay, so let's, before we dive into this too much, let's just jot down the numbers and see what's going on here. So let's say we've got two groups. We've got the ginkgo biloba group, and we have the placebo group. So the sample for the ginkgo group was 1,545. So there are 1,545 people in that group, and there were 1,524 in the placebo group. Okay, moving on. Among those in the ginkgo treatment group, 246 later developed dementia. So there was 246 out of 1,545. That was the sample proportion for the ginkgo group. And the placebo sample, it was 277. That was the sample proportion there. A little bit of new notation. Mathematicians never like to use p hat, the same symbol, to stand for two different measurements. And we really do. We have two p hats here. We have two sample proportions. So they're just going to be not creative and call it p hat 1 and p hat 2. And it's totally arbitrary which one you decide is group 1 and which one you decide is group 2. If you want to match what the book says, they will always just make the first one mentioned in the problem P1. So because they mentioned the ginkgo patients first, that the book will call those P1 and the placebo P2. Okay. So let's go on from there. Actually, then this is not really part of the process, but I'm just curious what those percentages actually are, how those sample percentages came out. So I'm going to get the calculator up here. Oh boy. Let's try that again. I wanted the Windows calculator. There we go. I think that if this was back at the start of the quarter, I think I totally would have started this video over, but at this point, I don't even care anymore. We're just going with it. Okay, so the ginkgo group was 246 divided by 1,545. Again, you don't really need to do this to analyze the problem. I'm mostly just curious. That was about 16% of the ginkgo patients got dementia. So that's approximately 0.16. And let's look at the placebo patients also. That was 277 divided by 1,524. That's more like 18%. Right. So at least in these samples, the patients on ginkgo got dementia at a lower rate than the patients on the placebo, but not much of a lower rate. And the question is that really convincing evidence here? It's pretty big sample sizes, so maybe that difference is convincing, but let's analyze. Let's not make a subjective judgment about whether or not this convinces us. Let's see what the numbers actually say. So we want to test the claim, come back up here, test the claim that ginkgo's effective. And part of the reason I wanted to do this problem is that word effective. Most of the time they say, test the claim that this proportion is lower than that proportion. And that's easy to set up the hypothesis. But here when they say effective, we have to translate that a little bit. And what they do mean is that the rate of dementia is lower for ginkgo. That's what it would mean to be effective in preventing dementia. So we have to do a little extra layer of translation there. But eventually I come down to saying that means that the rate of dementia in people on ginkgo is less than the rate of dementia on people that were just on the placebo. That's my hypothesis, one of my hypotheses. The other one is going to be the other direction. So this is a setup pretty similar to what we've always done with hypothesis testing. The one that has the equal sign in it becomes the null. The one that doesn't becomes the alternative. And we need to grab StatDisk and calculate a p-value. If you look in the book and you look at the formulas, which please don't, but the formulas are more complicated for two groups just because they're doing a lot of subtraction. They're looking at the difference between the two groups. So everything is this minus that. StatDisk is going to handle all that for us and just leave it to us to do the interpretation. So let's get StatDisk. So pull up StatDisk, and under analysis, go to hypothesis testing. And this time we want to do proportions, but we have two samples that we're comparing to each other. So let's get proportion, two samples. And let's set up our alternative hypothesis, which is proportion 1 not equal to, no, that's not what we had. We had proportion 1 is less than proportion 2. So proportion 1 is less than proportion 2. Significance level was stated in the problem. It's actually 0.01. They made the level a little more rigorous. They want to be really convinced, which is appropriate for medical situations. Okay, and then sample 1. That was our ginkgo group. And that, again, this is where it gets important to make sure that your hypothesis and your sample numbers are all talking about the same thing. So make sure you're careful with that. Sample 1 for us was the ginkgo group. It was 1545 was the sample size, the number of successes. I don't know if getting dementia counts as a success, but it's what we're tracking here. So 246 out of 1545. For sample 2, it was 1524 and 277 successes. And we are ready to evaluate. And notice our p-value. P-value is right there. It's 0.04845. With a normal significance level, that would just barely be unusual. And we would just barely be rejecting the null. Keep in mind, though, that our significance level is 0.01. This is not unusual for this problem. So let's go ahead and jot the p-value down, 0.0485. Again, normally that would be unusual, but for our definition, that is not unusual. Again, we had that 0.01 significance level. Not unusual, so we are not rejecting the null. So we are not rejecting the null. Because we are not rejecting the null, we can't accept the alternative either. So we need to write a sentence that somehow says that. And I'm going to talk about the alternative when I write my sentence, right? So I'm going to say, there's not evidence for the alternative, and translate the alternative back into words from the math that we have here. There's not evidence that P1, which is ginkgo patients, so there's not evidence that ginkgo patients get dementia. I cannot spell dementia. There's not evidence that ginkgo patients get dementia at a rate less than patients on a placebo. So again, I'm still basically saying there's not evidence that the first proportion is less than the second proportion. And when I write my sentence, I just need to say what those proportions actually are. Okay, so we've done part A. Man, this video is already 15 minutes long, but we need to power through and do part B. So it says, so basically we just said here, there wasn't convincing evidence that ginkgo works. Let's look at part B. Part B says, test the claim by constructing an appropriate confidence interval. Part of the beauty here, if you noticed when you looked at StatDisk, was it built the confidence interval for you right there. And okay, let's just copy this confidence interval down, and then let's talk about what it actually means. Let's see, so it's like negative 0.054. Comma positive 0.009. The key here to interpret these numbers, because you can look at those and you're like, what does that even mean? The confidence intervals here. Let's see, let me rewrite that. The confidence interval always expresses how much bigger group 1 is. Compared to group 2. Keep in mind that the ginkgo is group 1. All right, that's B1. Placebo is group 2. And this interval talks about how much bigger group 1 is than group 2. Negative bigger, by the way, is the same thing as smaller. So when we write our sentence here, sorry, I know this is getting messy. I'll put the sentence down here. So I'm going to use this idea to write a sentence down here. And this would say, something like the rate of dementia, the rate of dementia in group 1 in ginkgo patients is anywhere from, and now the interval says it's anywhere from 5% lower, and I'm going to round a little bit here, to, and I'm going to round this, round up to 0.01, so to 1% higher. Then the rate in placebo patients. So again, we're saying, hey, group 1 could be anywhere from 5% lower to 1% higher than group 2. And then just talk about what group 1 actually is and what group 2 actually is. Part C, based on the results, is ginkgo effective? No, not based on these results. For the hypothesis test, we could not reject the null. We said there's no evidence that P1's less than P2. And even the confidence interval says, hey, the rate of dementia in ginkgo patients might be lower, 5%, as much as 5% lower, but it might even be higher. It might be 1% higher than the rate in placebo patients. So if ginkgo makes a difference, we don't even know if it makes it better or if it makes it worse. And it could be that it makes zero difference, right? That's a possibility as well in this range. 5% lower all the way through to 1% higher includes the possibility that there is zero difference. Okay, I think really with this video we've got the whole story. I might do one more example just so you can see one more example worked out.